Rolling is possible when there is friction. On a surface without friction, rolling is not possible. And all the vehicles starting from a bullock cart to the aeroplane, they have wheels which are based on rolling only. That means rolling is the foundation of modern civilization, and rolling is not possible without friction. Here we have to see how the frictional force changes on the basis of applied force. The force applied starts from 0. Force applied is getting increased up to here. See, here, this range, force has been increased, applied force is increasing. Then we find that this is also increasing, this force. What is this? This is frictional force. But the motion hasn't started so far. That's why this is static friction. Up to this limit, this would be called static friction. Static friction. You go on applying the force, you go on increasing the force, but the border situation has arisen. Now the body is about to move. That means the static friction has reached its optimum, its maximum, its the highest value that you call limiting friction. This is called limiting friction. Limiting friction means the situation has taken place after which the start of motion will take place. We increase the applied force further beyond this. Soon as you increase the force, what happens? Suddenly this decreases. That limiting friction has gone little down and the body will stop moving. This is kinetic friction. In this region, it was static friction. The situation is crystal clear when you start applying force and start from 0, go on increasing regularly. What happens with frictional force? Initially it is static, it goes on increasing, becomes maximum, known as limiting, and then suddenly it reduces a little and then it becomes kinetic. It's obvious that kinetic friction is always less than static. Similarly, in higher advanced chapters we study about rolling friction also. You come across now 3 terms: static, kinetic, rolling. Rolling friction is minimum. This is rolling, this is kinetic, and here it is maximum static. So better to say limiting friction. In running matter, mostly we use the term Fs. We understand that this is maximum static because the formula that we use for comparison is always for maximum static friction, or you might say limiting friction. And then based on these concepts, we'll try to understand what is the term angle of repose. Angle of repose. Repose means rest. Just consider a plane, inclined plane. In fact, this is not the plane. I would take one example of a book. This is horizontal position. Consider this a plane whose inclination is likely to be changed. This is horizontally placed. One object has been placed on it. Object. and I try to increase the angle of slope, or you might say the inclination of this plane, there would be a situation when this object placed on the plane will start sliding this way. This is what we are interested in. This would be known as angle of rest. So how will you define the angle of rest or angle of repose? Angle of repose is the maximum angle of inclination of a plane at which the body placed on it will just start slipping down. So let's consider the block placed on this plane. Block has been placed. Its a weight mg, weight of the block. You can resolve this in two components, mg sine theta and mg cos theta. The reaction, normal reaction acting on the body will be exactly opposite to this component mg sine theta. N must be equal to mg sine theta, then only the body can remain at rest. N equal to mg sine theta. And the body will obviously be having the tendency to slip down the plane because this mg cos theta is regularly acting. This angle, I am extremely sorry, it is mg cos theta and this is mg sine theta. Here will also be a change. This is mg cos theta and mg sine theta is pulling it down the plane. Frictional force will be acting opposite to it. Since the body hasn't started moving down, this is static friction and maximum situation has arisen, so this becomes mu s into n. Put here mu s into n, that must be equal to mg sine theta in order to balance the forces. Then only it is likely to be in rest. And we are discussing only that border situation. Now take the ratio of the two. You divide the second one by the first one. You will find mu s n upon n. And this side you see mg gets cancelled. Here it is sine upon cos theta. Sine theta upon cos theta. Finally, you get one very important result. Mu s equal to tan theta. This angle that we call angle of repose, or you might say angle of rest, tan theta is equal to mu s. We must be knowing in studying friction that mu s is also equal to tan lambda. Lambda is called angle of friction. So what we can conclude here, that theta is equal to lambda. What does it mean? Angle of repose is always equal to the angle of friction. Lambda is here angle of friction. And what is angle of repose? Again I repeat, it is the maximum angle of the plane at which a body placed over it just starts slipping down.